Hello everyone, I'm back for a new week of maths. I hope everyone had lots of fun learning about 2D and 3D shape last week. It was wonderful to see how involved you all were, and you really got stuck into it and found some amazing things around your houses and lots of the properties about 3D shape using lots of those wonderful maths words. And I'm back in Mrs. Everson's office, and I've got Positive Panda joining me again for this week's maths. So I'm going to share my screen. Let's do that. Hopefully everyone can see that. Oh, I've moved on too quickly. So this week is all about fractions, and I think that this might be a new concept for you guys, because again, this was something that was missed just as we went into lockdown last year. So it's really important that we try and get that right for you guys this year. So what I thought we'd start off by doing is some practicing of number formation every day, because this is something that we do in school. And if anybody can read the screen, it says down and around, and I'm going to trace out my arrow so you can see. Or should I do this one with the so down? I can never do this very well on the mouse. I think Mr. Davis is amazing doing his write a repeat of handwriting. Down and around, then a flag on high. We've got our flag here. That's the way we make a 5. So pause the video now and have a go at that on a sheet of paper in front of you, or if you're really lucky, using a small whiteboard and a pen. Brilliant stuff. Lots of practice of forming 5s. Okay, what do you notice about the two shapes that are on here? We know that they are 2D shapes, fantastic, and we know that they are squares. That's why we always teach our shapes before fractions. It's really good to know. What do you notice? What's the same and what's different? So pause the video now and have this discussion at home or in the classroom. Yeah, so we could say that things that are the same is that they are both squares and they are both equal. They're both the same size. They both have the same amount of sides, the same amount of vertices. Okay, what is different? So I've used that word equal. The sides are equal. But what's different about this area in between? Fantastic. This one here has been shared equally. There's the same amount, oh, Mr. of your arrow, on each side. This one here, you have two unequal parts. This part has more in it than this part. This part here has less in it. A bit difficult to show you always on the screen, but here we've got, oh, let's undo that. Over this side, we've got equal parts, and on this side, we've got two unequal parts. They're different, they're not the same. Okay, so here's a challenge. Can you fold your square into equal parts? Can you fold your square into equal parts another way? So on this slide, we had it into equal parts this way. And on this square, can you find another way to fold your square? And I will put in with a line afterwards when you've had a go. So pause the video now and see if you can cut out a square at home, an equal square, and see how many different ways you can fold it to make them into equal parts. Brilliant stuff. So you may have folded your square horizontally, like I've done here. Does anybody know another way that you could fold your squares? I've got two equal parts here. They're both the same amount. There are two equal parts of the whole. The whole is the whole square. It's both parts. It's the two parts together. Anybody else got another idea of how we could fold our square equally? Let's move on and see if you've guessed it. If you need to pause the video now, then please do so. Brilliant. We can also fold our square like this, okay, on a diagonal. So we've still got two equal parts here. Can anybody spot the shape that this has made in this section or in both sections by folding it diagonally? Brilliant. It's made a triangle, hasn't it? It's got 3 vertices and 3 sides. One side, 2 sides, 3 sides. Brilliant stuff. Okay, I think before we move on to that, I just want to draw your attention to something as well. So I've been showing you in a square, but I'm just going to show you this because I think it's really good to use this visual representation, this model, to help you when we start looking at recording with fractions. So I showed you with a square and I said you could fold it diagonally, vertically and horizontally, but I'm going to show you here. And what does this look like? Because this is my hole in orange and I have put it into 2 equal parts. These are my 2 equal parts. Okay, I've got a cuboid shape here, haven't I? But what does this remind anybody of? If I hold it up together like this, what does this remind anybody of? The model that we've used, and we use this model with multiples. I'm going to give you a chance just to talk about this at home or in the classroom. Pause the video if you need to. Brilliant. It's like a bar model, isn't it? We have our hole at the top and we have our 2 equal parts that make our hole at the bottom. And we're going to be thinking about bar models throughout fractions because they're a really useful tool to help us with recording fractions. Okay, brilliant. Back to my screen share. We're going to go back. Let's share that. So we've talked about equal. Now, what I want you to look at now are these images that we've got on the screen. And it says, are these equal or unequal? So have they been divided, okay? Have they been separated into parts that are all the same amount, are all the equal amounts, or all different amounts, unequal parts or amounts? And we've got a sentence at the bottom that says there are parts of the whole. So pause the video now and talk about whether each picture is equal or unequal, and then we'll come back and we'll discuss in a minute. Fantastic. So let's go through the ones that we all thought were equal. Well, this one is equal because the parts are both the same. There are 2 parts. There are 2 parts. So we have got a whole out of 2 parts. So if I shade this in. Okay, and I've shaded half. Okay, I've shaded 1 part out of the 2 parts that there are. So I should have said this was the whole, really sorry. Over here, is this equal? Yes, it is. How many parts are here? Well, there are 4 parts here. And if I shaded in 1, I've shaded in 1/4, but they are all the same. Are these ones the same? I think they are. They are equal as well. And just like this one, we have got, oh, stop dragging that. Let's undo that a little bit. Let's start that again. This one's equal. And I have got 4 parts, 1, 2, 3, 4. They've all got the same amount in them. They all look the same size. They all look equal. So there's 1, 2, 3 circles in each. So I've got 4. And if I shade in 1, I've I've also got 1/4 shaded in. Now, these ones over here, they don't look equal. They look unequal because I've got smaller parts here to this part, and the same on this one. I've got smaller parts here to this part. So those pictures are unequal. So that's the start of fractions. I've started to record alongside you so we can look at how we record them. But really our first step is just looking at equal and unequal. Now we're going to start thinking about how we look at equal parts within an amount, within numbers. And this is your task for today. And I'm going to start you off, but actually you're going to go away after this and you're going to use the resources that you've got around you to represent Billy's balls. So Billy has got 24 balls. Billy wants to split them into equal parts. How many different ways can she do it? I'm going to read that again. Billy has got 24 balls. Billy wants to split them into equal parts. How many ways can she do it? So I've got her footballs down here and she wants to split them into equal parts. That means the same. So how many different ways can she do it? So just by looking and not even counting, I can see that we've got 1, 2, roughly, I'm guessing about 8 columns, because I can naturally see, I started to count, but then I thought, no, Miss Dar, just look, and I can see 8 columns. So I'm going to split these like this in half, like we've been doing today, and looking. And have I got the same amount in each of the parts? Let me just check, because I do want to double check afterwards. 1, 2, 3. Now I know how to count in 3, so I'm going to count in my multiples of 3 to make it quicker for me. 3, 6, 9, 12. So I've got 12 here in this part. And let's look at this one. 3, 6, 9, 12. Aha! They are both equal because I have 12 in one part and 12 in the other. But I want to know how many different ways can she do it. So this is your task. Go around the house. If you have counters from any of your games, if you could even use pencils to represent the footballs, anything you like, buttons, sweets. I tell you what, that would be an awesome way to do it. And your grown-up might let you. Can you use sweets or something really fun, or raisins, whatever you've got, to represent your footballs? Count out 24 and see how many ways you can split them into equal parts, so there's the same amount in each part. And I would draw a circle around your parts like I have to make it really visual and clear for you. And use this STEM language down here. There are balls, there are equal parts, and there are balls in each part. So in my case, there are 24 balls, there are 2 equal parts, and there are 12 balls in each part. So I'm going to leave you with this today. So if you want to stop here and pause the video and have a go at this, then that's great. I'm going to stop this share now. So I want to see photographs and sentences, whether that's you saying those sentences, using those STEM sentences, or writing them down. I want to see lots of photographs of that on your Class Dojo. Have lots of fun, and I will see you back tomorrow for our second maths lesson. Bye.